Hey Math 1, this is Mr. Roberts recording to you from Wednesday, October 31st. That's right, it is Halloween. And these are the answers to the questions that were on the index card that were handed out. So the first question asks you to simplify this. This is the simplified version of that. Number 2, the simplified version is this. Number 3, when you solve this equation, you should have gotten that x was negative 11 sevenths. That's number 3. Number 4, x was 3/8. Number 5, when you multiply, maybe you used an area model, maybe you didn't, but the product of that length times width is this. And this product is 6x squared minus 12. Find the equation of the line that goes through negative 2, 4, and 4, negative 1. This is the equation that you should have gotten. And then finally, the last question, by the way, notice the slope of this is positive 1/2. The last question is find the equation of the line that is perpendicular to the line in question 7. So because I'm told it's perpendicular, right, I'm going to be thinking my slope has to be the opposite reciprocal of this. So I need a slope of negative 2. And this ends up being the correct y-intercept way up here at 16 if the point's going through 5, 6. So those are the answers real quickly. Now I'm going to go back and do them if you need to see that. Okay, so now that we've gotten what the answers are out of the way, let's go ahead and take a look at some approach you might take to deal with these. In the first question, I probably, just looking at this numerator, would probably deal with raising a product or some powers. Well, it is a product to a power. So what I could do is I could raise each. There's two things being multiplied in here, right? There's this 3 to the negative second and the x to the third. I could raise each of those individually to the negative second power. And remember, when I have a power, for example, any a raised to the b power, that's a power. When I raise that to the c power, right? That means that I have c of these things. And if I write them all out and count them up, I would have exactly b times c factors of a. So it's multiplication here that I use. So this would become 3 raised to the negative 2, right? 3 to the negative 2 times negative 2, which would be 3 to the fourth power, and then times x raised to the negative sixth power. In my denominator, I've got 6, and I'm going to write it as 2 times 3, anticipating what's happening up above there. 2 times 3, and I oftentimes will just take numbers like this and I'll write them in their factored form. And then I've got times x raised to the third. So if I consider what's this next, right, there's a couple things I might do. I do see that in the numerator I've got 4 factors of 3, and I might rate that as 3 to the third power times one more factor of 3, right? That's 3 to the fourth, and then I still have this x to the negative sixth. And I might consider the fact that in my denominator there's a 2 times a 3 times an x to the third. So this is just me kind of figuring out that there's this giant 1. There's a common factor of 3 over 3 that I might choose to get rid of. Kind of wrapping this problem up, in my numerator I have the number 27. In the denominator there is the number 2. The other thing that I have in my denominator or actually in the numerator that I want to take care of is you can see that it's raised to the negative 6 power, x to the negative 6. So I probably would multiply both the numerator and denominator by x to the 6th. So I'm just multiplying by a giant 1 here. When I do that in my numerator, x to the negative 6 times x to the 6th is x to the 0 power. And of course, x to the 0 power equals 1. So this becomes just a plain 27 in the numerator. And in my denominator, if you look closely, I now have 3 and then 6 more, or 9 total factors of x. So it's x to the 6, 7, 8, 9th power. So again, as my final answer, I would write 27 all over 2x to the 9th power. So that is the answer that we were looking for the first one. Let's go to question 12. I'm sorry, question 2. So this one doesn't have these negative exponents everywhere, so this should be a little bit easier. So in the numerator, right, I can see that there is this 12, and there's also x to the fourth, x to the seventh. So I'm going to break this up as just 12 is 2 times 2 times 3. Not necessary, but I'm going to write it like that. And x to the 7th is how I'm going to write the x to the 4th times x to the 3rd. In my denominator, I've got a 2x, 2x. If I write this out, 2x times 2x. So you can see there's a couple ones here, right? This 2 over 2, those are both factors. There's another 2 over 2. That's a factor that's equal to 1. If I clean it up just another step, because I'm losing track of things, I could write this as 3x to the 7th power all over x squared. So you can see that there are two factors of x that both the numerator and denominator share. So I could spell this out very clearly, 3x to the 5th times x to the 2nd and all over x to the 2nd. So those are going to be gone. So I'm left with just 3x raised to the 5th power. So that was the answer to the second problem. Moving on, the third. Let's see. The third one, right, remember the answer should be 11, negative 11 over 7. So as I look at this, I can see with the number 1/3 and the number 9 that the base that I'm going to want to migrate towards is a base of 3. I've told you that the the only way that we can solve exponential equations in this course is by rewriting these so that they have the same bases. So if I consider some bases of 3, right, I think I wrote this in class yesterday. I've got 3 to the 0 power, of course, is just the number 1. But I've also got 3 to the 1st is 3. 3 to the 2nd is 9, which is what I wanted, right? 9. 3 to the 3rd I don't need, which is 27. And if I go the other way, right, when I go forward, I'm multiplying by 3, but I can go backwards by dividing by 3. So 3 to the negative 1st power would be 1 divided by 3, or 1/3. 3 to the negative 2nd power would be 1/3 divided by another 3, put another factor of 3 in the bottom, so that would be 1/9. So the two that I need are here. I can see them, right? I have a way of writing 1/3 as a base of 3, right? 3 to the negative 1. And I have a way of writing the number 9 as a base of 3. So we're going to go ahead and go to each of these. And I'm going to go ahead and write down 3 to the negative 1 power instead of 1/3. So this is going to look like 3 to the negative 1 power. And I'm going to raise that to the x plus 1. And that's going to equal 3 to the 2nd power. There's my 9 again, and then I'm going to raise that to the 3x plus 5 power. So if I take a look at this, right, when I raise a power to a power, the key here is multiplication. So I'm going to have to multiply this 3 to that power times this. That's going to involve the distributive property. I'm going to multiply the 2 times this exponent. So I'll rewrite this again. Kind of didn't leave enough room for that, but I'll write it over here. This is going to become 3 to the negative x minus 1 power, and that will equal 3 to the 6 times x plus 10 power. Okay, so this is the place where we want to be, right? We've got identical bases. The bases are both 3. The only way that these can truly be equal to each other is if these bases are equal. So I simply just set the bases equal and solve for x. So the opposite of x minus 1 must equal 6 times x plus 10. I could add x to each side. So if I did that, this would become negative 1 equals 7x plus 10, and I could certainly subtract 10 from both sides. So negative 11 equals 7x, and then finally if I divide by 7, I get that negative 11 over 7 is what x is. So x is negative 11/7, and I hope that's what I got. Yeah, x is negative 11 over 7. All right, let's move on to question number 4. Here's 4. And I don't feel like I have enough room to do 4, so I'm going to take this and move it. Oh, no, everything's getting crazy on me. Let's not move anything. Okay, that's better. So for me to break this up, right, to get rid of the fractions, right, the technique we've talked about is the fact that I can push through factors across this entire equation that will eliminate all the fractions. And the factors that I want to push across, I'm going to definitely need a 2, I'm going to definitely need a 3, and I'm definitely going to need a factor of x. So you can see my whole strategy here is just to bring in some new factors, and it's going to go here and here and here. Every single one of those numerators are going to get a new 2 times 3 times x, or 6x. I prefer to leave them written like this because it makes it easier for me to see where my ones are. So let's begin. I've got the 2 already, right, over x, plus there's a 4 over a 3, and then that's going to equal the 5 over the 2x. So all I've done is I've rewritten this equation with room for my new factors that are coming in. And here they come, right? On the left-hand side, there's 2 terms, and they're both going to get it. So here's a 2 times a 2 times a 3 times an x, times a 2 times a 3 times an x, times a 2 times a 3 times an x. So this is a perfect situation because I can see all of the giant ones, right? X over x equals 1. There's a 3 over 3 that equals 1. There's a 2 over 2 that equals 1. And then there's also this x over x that equals 1. So the fractions are completely gone, and the resulting equation is 12 plus 8x equals 15. If I take away 12 from both sides, I get that 8x equals 3. And if I divide both sides by 8, I get that x is 3/8. So x is 3/8 was the answer for question 4. All right, question 5 and 6 both ask us to multiply some binomials and one monomial times a binomial. So when you're doing these multiplications, right, it might be helpful to use an area model, or it may not be necessary. If I was to do 5 with an area model, it would look like this. And I would be multiplying an x and a 1 and a 3x and a 5. And you can see this box would become 3x squared. This box becomes 3x. Up here I get 1 times 5 is 5, and then finally x times 5 would be 5x. There are 2 like terms, right? These are like terms, and I can combine them. So when I write this product out, I do get 3x squared plus 8x and then plus 5. So this is the product of those binomials. For the second one, I don't need an area model, right? I'm just multiplying each one of these inside terms by 3x. So 3x times 2x should give me 6x squared, and then 3x times negative 4 should give me a minus 12x. So this is that product. Last 2 equations, it says last 2 questions rather. It says find the equation of the line that goes through these 2 points, and you can see the answer is already there. Let's take a look at this. First of all, of course, I'm going to find the slope of the line. The slope is the change in y over change in x, so I'm going to double underline my y's, and I'm just going to go ahead and write -1 minus -4. That's the change in y. I'll simplify that. -1 minus -4 is -1 plus 4, which looks like my -1 plus 4, which looks like a change of 3 is in the y. And then let's do the same thing for x. You can see my x's are here and here. And I did start with the -1, and I went this way to subtract. So I'm going to do the same thing with my x's. 4 minus -2. 4 minus -2, which is going to give me 4 plus 2, which gives me 6. So you can see the slope is 3, 6, up 3 over 6, which reduces to 1/2, up 1 over 2. So I've got a slope of 1/2. The other thing that I need is I need to know the Y-intercept. And we'll talk about simpler ways to do this, but for now the technique that we keep using is we consider one of our points here. I've got an x and I've got a y, right? I'm going to use this second point. I've got an x and a y, and I know my slope is 1/2. So I just write y equals mx plus b as a reminder. My value of y is -1. My slope is 1/2. My value of x is 4, and then I've got the plus b, which is nice because everything here is a number except for this this right here, right? This is going to allow me to figure out what my y-intercept b is. So I've got this -1 equals 2 and then plus b. I think so. Yeah, 1/2 times 4 is 2. And if I subtract 2 from both sides, I get that -3 is what b is. So at this point, I have the slope and I have the y-intercept. So that means I can write the equation of the line. The equation of this line, and you can see there's my slope, there's the y-intercept, and you can see this is the answer, right? Y equals that slope times x, and then plus this -3, right? Minus 3. And then the final question says, hey, find the equation line that's perpendicular to the line that goes through 7. And as I already indicated in the video, hey, because this had a slope of 1/2, the slope we're talking about down here has to have a slope of -2. So anytime lines form at right angles, they will be opposite reciprocals of each other. So their slopes have that relationship. So that means I know again a slope, and I have an x and a y value from this point. So I'm just going to go ahead and write y equals mx plus b. My y value is 6. My slope is -2. My x value is 5, and then here is the plus b. So y equals -6. I'm sorry, 6, which is my y value, equals -2 times x plus b. That means that 6 equals -10 plus b, and if I add 10, it turns out 16 is my y-intercept. And I know the slope, right? The slope was -2. In fact, it's written right here. So that means the equation of my line is y equals -2 times x and then plus 16. This is the equation of the line that is perpendicular to this line. It makes a right angle with this line. They would be at 90 degrees to each other. And this line goes through the point 5, 6.